Hello, in this video we're going to be taking a look at evaluating exponents. This is a topic that can be connected to order of operations problems, evaluating problems, anything along those lines, basically anything relating to number sense or number operations. Um, so, Exponents, we're going to start with 5 to the third power. We'll explain, or I'll explain, the little theory behind it, how we can evaluate this both with or without a calculator. So 5 to the third, a quick simple error that hopefully we're aware of at this point. This would not be equal to 15. 5 to the third power does not mean 5 times 3. Okay? What does 5 to the third power really mean? Let's think about that for a second. First of all, exponents indicate repeated multiplication. In other words, an exponent is telling you how many times to multiply that particular number, which we can refer to as the base, by itself. So 5 to the third really means 5 times itself 3 times. Okay, which would be 5 times 5, which is 25, times an additional 5 would give us a grand total of 125. Kind of break it down like that, really turns into a problem that's not that difficult, turns into a multiplication problem. If you try to do it in your head, you might run into an error, obviously. Fractions. Fractions with exponents, we can think of in the same way. So we can think of 2/3 to the fourth power as 2/3 times itself 4 times. There is an additional property here with fractions that we can take into consideration. The property that we can kind of extend that exponent that's outside the parentheses, or that's outside of the fraction, to both the numerator and denominator separately. What do I mean by that? In other words, instead of thinking of this as 2 to the third power, 2 over 3 raised to the fourth power, I could think of this as 2 to the fourth power divided by 3 to the fourth power. I am allowed to do this. It's almost like a distributive property in a way, where I'm distributing the 4 to the numerator and the denominator. Okay, either way kind of makes sense and works, so that we could either do what we had on the bottom there in green, do what we have over here in purple. Either way, we should arrive at the same answer. 2 times 2 times 2, or 2 to the fourth power, should be 16. And on the bottom, 3 to the fourth power, or 3 times 3 times 3 times 3, should be 9 times another 3, 27, times that fourth 3 gives us 81. Okay, and 16 and 81 are relatively prime, meaning I can't simplify this any further. So my answer would simply be 16 over 81. Once again, with fractions, we can apply this property of distributing whatever is outside. It does have to be written like this. Okay, so if we have a over b to some power c, we can write it like this. Important property for exponents, something to be aware of. Can help you simplify it. Sometimes you might just be simply asked, hey, what's equivalent to this? And you simply might have to match something like this, what we just boxed in there. So knowing that property can definitely be useful. And last problem we're going to take a look at here, taking it up a little notch, evaluating an expression that involves exponents. So anytime you're evaluating, we're simply, quote unquote, plugging in. So I'm going to plug in a 9 where I see an A. So this is kind of like combining order of operations, evaluating, and exponents all in one little nice bundle here. Okay, so I'm going to take care of my parentheses first. So that should be 4 to the third power. On the left, 4 times 9 is 36. And 4 to the third power, going off what we said earlier, really means 4 times 4 times 4. We know 4 times 4 is 16. When we add that additional 4, we're going to get 64. Just be careful, doing something like this quick. The very first error we talked about, you don't want to take 4 to the third and write 12 underneath it. So actually think about what it means, write it out if you have to. Doing 16 times 4 doesn't really amount to that much work, so simply write it out. And last step here, adding together the two numbers, we should get a nice clean answer of 100. 36 plus 64. Okay, so this video on exponents, going through some of the properties and how they can be applied to noting equivalent expressions by applying some laws or properties of exponents, and how to evaluate expressions with exponents. Thank you for watching.